Let's start. So this is the recorded version of this chapter, the fundamental probability. Unfortunately, yesterday, guys, there was some technical error because of which the live recorded lecture wasn't recorded, right? So I have to redo it. I know it's kind of irritating, but I'll try to cover up or cover this topic as comprehensively as we did in the live class. So keep that in mind, and I'll cover everything, right? So let's get started, right, without much further ado, right? So the point here is that this is the first topic of your quantitative analysis. Quantitative analysis is book number 2. Very, very important for your FRM. Book number 2 is the foundational book for your topics of FRM, right? And even that continues in your FRM part 2 also, because there is no quant in FRM part 2, right? So if you think the basics of quant starts from here and it's are covered FRM part 1, and then it is assumed that you have learned the basics of FRM part 1, or basics of quants in FRM part 1, and that knowledge will continue in FRM part 2 as well. So this is a very foundational kind of book. But is it easy? No, it's not easy at all. The first chapter might seem easy to you, but slowly the level will increase and things will become very, very difficult, right? So pay attention, understand what is the topic. The topic is fundamentals of probability. Probability, we all know probability is likelihood. Probability is chances. So we are talking about fundamentals of probability, fundamentals of calculating the likelihood, fundamentals of calculating the chances. Why we need to understand probability, right? Because in finance, when we deal, we are trying to ascertain the future. We're trying to forecast. And when you're trying to ascertain the future or forecast, you just can't put numbers to it, right? You have to put probabilities because there's nothing certain. Everything is quite uncertain, right? So please pay attention that when we are talking about future, when we are trying to forecast, when we are trying to look in the future and predict something, we cannot say something with certainty. The only way to convey the idea is through probability, through likelihood, through chances, right? So that is your fundamentals of probability. All right. So let's get started. So fundamental of probability divided into two parts. One is the basics of probability. Another is your conditional, unconditional, and joint probability. Not very difficult topic, guys. Very easy. I'll try to make it as interesting as possible. Okay. Moving on. So the first part is we'll try to understand the basics of probability. Then we'll deep dive into what is events and event space. Then what are your independent and mutually exclusive events? Very, very important. Then your conditionally independent events. Very tricky. Not so important, but yes, look at the theory part, right? Students who are new to this book or students who are studying this topic for the first time with me, please pay attention that I, as a teacher, not only teach but also guides and mentors students where to focus, where not to focus, right? So my duty is not only just to teach you the concepts. I tell you very clearly that how a certain topic will be tested in exam, right? So that's how I teach, right? So in this part, I'm just trying to say that if you look at this part of your subject, right, this is very important. The topic number 3, independence and mutually exclusive events, very, very important. You have to deep dive here. And when you go to topic number 4, this is one of the toughest topics, very tricky, right? And here focus more on theory. The topic number 4, focus more on theory, less on numericals, because this is very tough. We'll come to it, but you'll realize that conditionally independent events is a very, very tough topic to understand. So examiner also knows it. People like me only set your paper. So we know it very clearly. This topic is very, very complex. So the thing which is asked in exam is more about theory, right? I'll tell you what to remember, what not to remember also, right? So let's get started. The objective of giving you this idea is that if you are preparing, right? If you're preparing, you should be very clear that where to focus. focus on this part, both these independent and mutually exclusive events. Go deep, go as much deep as possible, right? Whereas in conditionally independent events, focus more on theory. Okay. Then we're talking about basics of probability, right? When you talk about basics of probability, as I told you, right, it is a method or a system to find the likelihood of a certain event, right? Likelihood of a certain event. The first thing is understanding a random variable. Random variable is the unknown outcome, right? Let's say we are flipping a coin, right? We don't know whether it will come head or tail, right? We have no idea. So that is a random variable, right? When we don't have any idea about the outcome. Tomorrow's temperature, right? Don't have any idea, right? When we are rolling a die, when we are throwing a die, we don't know whether one will come, two will come, three will come, four will come, five will come, six will come. I'm talking about a six-side die, right? I'm rolling a die. I have no idea what it will come, right? The die which we use in games like Ludo, etc., right? So random variable is where we don't have any kind of idea. Then probability interpretation, I think that I have told you already. Probability interpretation is it gives us the likelihood of occurrence. When we flip a coin, whether it comes head or tail, 50%, right? Chances of there are only two possibilities, head or tail. So 50% chance of heads, 50% chance of tails, right? So that's what we have, right? Probability range, please keep in mind probability falls between 0 and 1, right? Probability can never be more than 1 because 1 means something which is certain, 1 means 100%. So probability can never be more than 100%, right? 0 means the event is impossible, right? Event is impossible, so we cannot have probabilities more than 1 or less than 0, right? Probability will always be between it, right? So when we say that, right, it's a 50% chance of something happening, right? So means the probability is 50% or 0.5, right? That's what we have. Next is this is important, guys. These three things are very important. Let me put it with other colors. I'm making star marks. Conditional probability, very important. Unconditional probability, very important. Your joint probability, very important, right? These three things are very, very important. You need to have an idea about this. So please understand. Conditional probability is something where you are putting a condition. You are putting a condition. So we can discuss it in your maybe next slide. We can discuss. Have they discussed ahead? No, they haven't discussed. So I can discuss it here. Okay. All right. So when I talk about your conditional probability, the conditional probability, when I talk about what we need to understand very clearly that conditional probability is dependent on a certain condition. When I say what is the probability of A dependent on the condition B? See, first you understand probability of A. Probability of A, let's say, is probability of traffic jam. So let's say you go to your office in whatever city you are. You say that I travel early in the morning. That time, probability of traffic jam at a particular junction is, let's say, 40%. Okay. Then I add new information. And I tell you that, okay, normal days, the probability of traffic jam is 40%. But today it is raining. So B is raining. So I have added the condition, one more condition that it is raining. Now, since I've added one more condition, it is raining. So it means now I'm asking you, what is the probability of traffic jam when it is raining? And you know that, right? In Indian cities or worldwide, whether it's New York, Hong Kong, Singapore, India, Mumbai, Bangalore, Delhi, anywhere, right? Whenever it rains, the traffic moves slowly, and it get delayed. So you will say that, oh, if it is raining, then my new probability might be 60%. See, without the condition, probability was 40%. When we put a new condition that it's raining, the probability of traffic jam becomes your 60%. The probability of traffic jam when it is raining is 60%, right? But we have to dig deeper, guys. Please understand conditional probability. The formula for conditional probability is this one: A intersection B over PB. This will come ahead, but I'm just giving you right now. Please remember the condition B, which is the condition, always come in denominator. This and this can also be written. This piece also remember A intersection B can also be written as this thing, which is basically also known as your joint probability. Joint probability of two items together. Okay, so we will see all these things ahead, but I'm just trying to build. This is joint probability of A and B together, and this is your probability of B. Okay, so that's what we have. All right, now once we go ahead, okay, one is what is unconditional probability. When I talk about your unconditional probability, right? When I talk about your unconditional probability, what I mean is that probability where there are no conditions. Marginal probability is another name. Probability without condition means that was similar to your probability of A, right? Probability of A. And joint probability, I told you, right? That is PAB, which can also be written as probability of A intersection B. Very simple, guys. School stuff, 9th, 10th class, 11th class stuff. Not very difficult at all. Okay. Moving ahead. This I covered. Next one is understanding what is an event and what are the event spaces. Again, don't stress yourself too much. Please understand, event is something where you're talking about a single outcome, right? Or a combination of outcomes, right? Let's say we are talking about that we are throwing a die, right, for a six-sided die. And then you say, what is the probability of x coming 3, right? If x coming 3 probability you are looking at, see, what are the possibilities when you roll a die? Either it can come as 1, either it can come 2, either 3, either 4, either 5, either 6. There are 6 possibilities, na? 6 possibilities. Out of these 6 possibilities, I'm asking you probability of 3. You will say that, okay, 3 is one of the 6, so the probability is 1 out of 6, right? Total possibilities are 6, and out of 3 is one of them, so probability is 1 out of 6, right? So this is your event. Similarly, somebody asks you probability of getting 3 or 4. You will say, okay, 3 or 4 means you are asking probability of 3 also and 4 also, which makes it 2. 2 possibilities out of 6, right? So 2 by 6, right? Probability of getting an even number, right? How many even numbers we have? So if I have 1, 2, 3, 4, 5, 6, we have 2, 4, and 6. 3 out of 6, right? 3 out of 6. Very straightforward. This is called event. When we talk about event space is all the possibilities together, right? So when we are flipping a fair coin, it includes your head, your tail, your head and tail, or neither head nor tail. Now you will say, sir, what do you mean by head and tail? Neither head nor tail. See, I'm trying to give you everything, but point is head and tail can't come together, so it's a will not consider, and neither head nor tail is also not possible. It will fall on one side. So eventually you will say that okay, there are only two valid possibility which are head and tail. So it is 1 out of 2, which means 50%. Okay, so event space is a set of all possible outcomes, right, and combinations, right? So in this case, rolling a die, you cannot get 2.5, right? When you throw a die, can you get 2.5? No. Can you get 3.5? No. Can you get 4.5? No. You can't get that, right? You can only get 1, 2, 3, 4, 5, 6, right? If that is the case, you can get it, right? Those are all the possibilities. So there are how many? What is the set of all possible outcomes? There are 6 possibilities, right? Which are 1, 2, 3, 4, 5, and 6. Okay, keep that in mind. Very straightforward, very simple. All right, moving on, guys. Practice question, not very difficult. For the roll of your fair-sided die, how many of the following are classified as events? How many of the following? Following are these 1, 2, 3. 1, 2, 3. How many of the following? Outcome is 3. Yeah. 1, 2, 3, 4, 5, 6. Right. We have 6 things, and outcome is 3, which is possible. One of the outcome, right? So this is an event. The outcome is an even number. Yes. Even, right? The outcome is the even number. Right? Yes. The outcome is 2, 3, 4, 5, 6. So outcome is not, outcome is not 2, 3, 4, 5, 6. The total things are 1, 2, 3, 4, 5, 6. Outcome is not 2, 3, 4, 5, 6. means you cut this, you're talking about this only, right? So yes, that's also an event, right? So all three are event, right? So yes, three, right? Moving on, guys. Till now, it is very easy and simple. So the answer is given here. All right, from here, the difficulty level now increases a bit. And I told you, right, this is the part where you have to dig deeper, right? You cannot keep it casual. Now you have to make it very, very solid and very, very effective understanding. So we are talking here about first is independent event. Please understand, independent event is when we are talking about two events where the occurrence of one event has no effect on the occurrence of other event. The outcome of one does not affect the probability of another, right? What kind of this event could be? So the example which I took in class was that if it is rain in Cameroon, that has no effect on rain in your Mumbai, right? Because these two places are quite far. Had it been Sri Lanka or something, I could have still considered, right? Or had it been some disturbance on the west, we can still consider. But Cameroon and India are very far, right? So there's no effect, right? So they are totally independent events, right? But do we have to just satisfy with the definition? No. See, the point here is from now onwards, if you see anything like your independent event, mutually exclusive event, any kind of thing, right? The first thing which should come to your mind is your mathematical formula, right? So mathematical formula, there are two conditions for independence that you have to remember very, very clearly, and you should be very clear of that, right? Very clear. One is that your probability of A, two events are independent, that means probability of A into probability of B is equal to probability of AB, right? Guys, this is only for independent events, right? This is only for independent event. Joint probability is the product of your unconditional probability in independent events. This is condition for independent. And next is your conditional part. Conditional part is probability of your A conditional on B is equal to your probability of A, right? So this looks like a difficult thing, but it's actually not a difficult thing, to be fair. See, we just saw, I told you the definition part, that this can be represented. Earlier slide I told you that I can write this as probability of A intersection B, and the condition which was there has to come in denominator. Then I told you that this can be represented, A intersection B can also be written as your joint probability, and you can write like this. And joint probability by this formula above, right? This formula above, you know that I can write joint probability as what now? Probability of A into probability of B, and it divided by your probability of B. So you can cut this, and it comes on probability of A, right? So you can remember this part very efficiently, or you can derive it also, not very difficult. The point here is that conditional probability of A given B is simply the unconditional probability of A. This is a derived kind of equation, but since exam wants you to remember it, please remember it, right? So keep that in mind. Uh, Example of this is that if you're trying to flip a coin twice, getting hands on the first flip doesn't change the probability of getting hands on the second, right? Because coin is fair, right? When you how many heads you are getting in a previous tries does not affect what will happen in the next one, right? So this is your conditional probability used for understanding of your independent event, right? So this part is done. Now we have mutually exclusive event. Mutually exclusive event means events which cannot exist together, right? So if I'm flipping a coin, I cannot say that I'm getting a head and tail together, right? Either it will be head or tail, right? If it is head, it cannot be tail. If it's tail, it cannot be head, right? So if the stock price is going up, it cannot go down. If it's going down, it cannot go up, right? At the same moment, right? So mutually exclusive event means that both events cannot happen simultaneously, cannot happen together, right? Both cannot happen simultaneously or together. For a single die roll, if x is an even number, you know that it cannot be 3, right? Because 3 is an odd number. It's mutually exclusive, right? So the point which you should take away from here is, see, understand. I told you to remember this part. I told you to remember this part, these two. I'm telling you to remember this part. I'm telling you to remember this part. A and B are mutually exclusive, right? AB is equal to 0, right? I'm telling you to remember this part. Okay, so this is the other part I'm trying to remember, or I'm trying to kind of you to focus on, right? So please remember, if two things are mutually exclusive, the joint probability AB for them is zero, or in other words, the intersection of anything, because there is nothing common between them, right? Head and tail has nothing common between them, right? Even and odd has nothing common. So intersection is zero, right? So remember this property, guys. Remember. Then we have the general addition rule. General addition rule is very important to understand, guys. Please understand. I'm putting it with another color. A lot of people get a kind of confusion here. I want to put it very properly, that this is a universal rule. Right? It doesn't matter something is independent or not independent. This is a universal rule, right? So, like, not the above one, right? This is a universal rule. The general addition rule is the universal rule. Then for mutually exclusive, things are changed, right? So what have been done? Let me put it in the next slide. So what is the general rule here? Please remember, when you talk about the general rule, the general rule is that probability of A union B, which can also be called as your probability of A or B, probability of A intersection B, which can also be called as probability of A and B, right? Or it can be called probability of AB, joint probability. Then probability A and B, right? So the general rule which is applicable to all independent or dependent is probability of A union B plus probability of A intersection B is equal to probability of A plus probability of B, right? So if I have to find A union B, right, probability of two things together, I can say it is probability of A plus probability of B minus probability of A intersection B. In this case, mutually exclusive events, right? What happens in mutually exclusive events, right? If we have, just a second, if we have your mutually exclusive events, what happens is that you have what? This part is zero. Why? Because we just studied, right, that PAB in mutually exclusive is zero. So it becomes PA union B is equal to PA plus PB minus zero, right? So we can say that it is PA union B equal to PA plus PB. Okay, so mutually exclusive, it becomes this, but otherwise in general, this is the formula, right? Please keep that in mind. For mutually exclusive, this part is zero. Very straightforward, guys. Very straightforward. I don't think there should be any problem till now. Which we have discussed, mutually exclusive, it becomes zero. Otherwise, it is A intersection B, right? Very simple. But remember these formulas, guys. From now onwards, you should focus on understanding the formulas rather than anything else. So it is very important that you have a strict command over your formulas, right? You should not be relying only on definition. You should, whenever you hear something, you should quickly, your mind should work quickly towards converting that theory into your formulas. Okay. Okay. All right. Let's do the question, right? I don't think the question is difficult at all, right? Let's try to do the question. We talk about the question: which of the following equations does not imply that the events A and B are independent? We have to check it, right? Independent events, what did I tell you? Independent events, I told you that independent events, probability of A, B, intersection B will be PA into PB, right? So does not, so this is okay, this is perfect. You want does not, so this is exist. Next one, PA or B, right? PA or B, all right, is equal to PA plus PB minus PA intersection B, right? What did I tell you about this, right? I told you about this is that this is a general rule, right? It doesn't matter whether something is your independent or not, right? So most likely this is the answer, right? But let's see others. PAB, right? This is also the general. This is also the independent property which proved na, that A equal to PA intersection B or PB, and A intersection B. I told you, right? We can write it as PA into PB into probability of B, right? Right? I understand it, right? So this is also independent. And then what about this? Let's try to navigate this. What happens here? If it is independent, you have what, AB, right, divided by probability of B is equal to probability of A. What is happening here? Okay, if you see this, okay, it's again same thing. AB can be divided into your probability of A into probability of B, right? And if it is existing, right? So if I'm getting this relationship, it means A and B are independent. This also, right? So we have to find out does not. This is does not. Okay, very straightforward. If you know the formula, that's what I was telling you, right? Remember the formulas, remember the context. If you know that, you are fine. If you just learn definition, that's not how FRM works. Okay, B is answer, perfect. Now we are moving to this topic, right? What did I tell you about this topic earlier? I told you very clearly that this topic, conditionally independent, right? Very tough, very tricky topic. So the numericals here will not come. Numericals won't come from here. What will come is understanding of this line. I'm telling you guys, in this slide, there is nothing more important than this line. Please remember this line properly. This is the most important line of this thing. This topic is very tricky, very tough. See, this topic is talking about conditionally independent. Conditionally independent, right? So earlier, what we studied? We studied conditional probability. Now we are saying conditionally independent event. We are putting a condition also, and we are saying independent event also. See, earlier we studied conditional probability. We're talking about conditional probability. Now we are saying conditionally independent, which is very weird to say, na? Conditionally independent. Okay, so we are putting a condition also. We are saying independent also. Conditionally independent. What's a conditional independent thing is that something which is independent or dependent depending on your conditions. Events can be independent unconditionally but conditionally dependent, or vice versa. Events can be conditionally dependent, right, and independent, vice versa, right? So the point here is that there are certain events in the world which behave totally independent, but when a certain condition is met, they become dependent, or a certain events which are dependent, then when a certain condition comes, they become totally independent, right? So why this is important to understand is because there are a lot of things, right? One of simplest example I can give is that in normal scenario, your normal condition, when investors are investing and when your monetary policy is same, etc., right? In normal condition, when investors are investing, right? What happens is that what happens in normal condition? What happens? That the returns on the bonds, returns on the stocks, okay, returns on the bonds and the return on the stocks are different, right? They're not same, not same at all, right? So people are investing money according to their risk preferences. So there is no relationship, right? In normal condition, there's hardly a relationship what is the between bond and stocks. But let's say the Federal Reserve meets and decides to change your interest rate. In that case, bonds and stocks are kind of dependent. Why dependent? Let's say Federal Reserve hike the interest rate. If the interest rate is high, most of the people will say that I'm getting more interest. Let me shift my money from stocks to bonds. So money will move from stocks to bonds. In case the interest rate is decreased, the money which is in bonds move to the stocks. So the flow of money which happens from bonds to stock and stocks to bonds is dependent on a external factor, which is a Federal Reserve decision on the interest rate. So depending on a certain condition, depending on the certain condition, they are dependent, conditionally dependent. Otherwise, they were independent. Events can be independent. Bonds return, stocks return were independent events unconditionally. But as soon as the Federal Reserve chairman's, decision comes, it becomes dependent. Okay, so that is the case. You have to remember. But again, the point here is the formula, etc., is very tough. The formula is given above. Is your probability if there are two conditional probabilities, AC and your BC. There are two conditional probability, right? R. They have two conditional probability AC and BC. They are conditionally independent. They are conditionally independent. Okay, when probability of AC and probability of BC is probability of ABC. But with my 15 years of experience of teaching, guys, I have never seen a question on this. Never ever seen a question on this. That's why I'm telling you in this topic. See, I told you very clearly when I was teaching that I not only teach concepts but also guide student mentors them that where to focus on. The focus area is this. If at all a question comes from here, the question will come from here. If at all a question comes from here, will come from this line, right? So please remember that it's a very tricky concept. It's not easy to understand, right? One of the example given here, event A is score above average on an exam. Event B is somebody is taller than average. For grad school students, probability in A and B might be dependent. Taller students might be older or better. However, we introduce event C, age equals 8. And PAC and PBC might be independent among 8-year-old, right? So it's taken a vice versa approach that something which was dependent, right? We use no vice versa. Something which was dependent on a condition, they might become, when we put a condition age equals 8, they might not correlate with the exam score. So it can be opposite also. Something which is dependent might become independent. So we have two examples, guys. What was happening here? The first example which I wrote in the green color, where events were your independent, but when a condition came, they became dependent. So earlier events were independent. On condition, they became dependent. Right? On condition, they become dependent. What is the opposite of that? What is the opposite of that? What is the opposite of that? The opposite of that is something which is your dependent becomes your independent, which is given here. Right? Opposite is given in the yellow line, right? Which is given in the slide, right? So remember that. Okay. Interesting example. Keep in mind. But again, don't focus on the don't focus on the numerical. Focus on the star which I made the line. Okay. All right, this is where I told you, right? Theory will come into picture. Two independent events must be conditionally dependent. No, there is nothing called must, right? There is a condition, right? On certain conditions, they become conditionally independent and certain not, right? So, no. Cannot be, no, they can be conditionally independent, right? Maybe conditionally independent or not conditionally independent. Makes sense, right? Are conditionally independent only if they are mutually exclusive. I didn't say anywhere that it is related with mutually exclusive, right? I didn't say at all, right? See, that is the beauty of remembering properties, guys. If you remember the properties, you can kill this question very, very fast, right? I didn't say this anywhere. Neither I said you must and cannot. Right? I told you on certain conditions you have conditional independent, and certain conditions it's not. So maybe or not. Right, so answer is C. Right, very straightforward. If you know the properties and the condition, very easy. If you know the properties and condition, very, very difficult if you don't understand properties and conditions. So it eventually boils down to your understanding of your properties and conditions. Okay. So keep that in mind. And then, yeah, moving ahead, guys. Next one, this is done. Then we have understanding of your. We're moving to the next part, guys. Moving to the next part is, so what we can do right now is we can take a small break, right? And after taking the small break, we can start again, guys. Okay. So small break and then we start again. Thank you. All right, guys, let's start after the break. Small break just to, start again. Next part. Next part. So, for people who might have missed out, we have completed the first part of the lecture where we talked about your conditional probabilities, independent events, mutually exclusive events. Now we are entering to the module 2, right? We have studied the numerical also. We are entering into your conditional, unconditional, and your joint probabilities, right? And so this is tricky, guys. This is very tricky, right? In fact, I will not complete this fully here because in my your live class today, which is after this recorded version, I will be covering this base rules, right? So we'll stop here in the base rule. We'll only cover the first two, right? And we'll stop here. Okay. So the point which I want to make here is that this is very important. Like, this is where the theory meets the formulas, and we need to have a deeper understanding of these topics, because if we have the deeper understanding of these topics, then only, right, we will be able to solve the numerical. So first is discrete probability function. We'll study, right? Okay, so we're talking about discrete probability function, guys. Please understand, this discrete probability function is not like your probability. It's very different. It's a function. It's a discrete probability function. Now, just want to give you an idea that when you talk about probability function, there are basically, in your syllabus, there are two kinds of probability function. One is your continuous probability function. One is your discrete probability function, right? One is a continuous probability function, one is a discrete probability function. Okay, so when you talk about this probability function, continuous and discrete, the point here is that discrete probability function will talk in this chapter. Continuous probability function will talk in the next chapter. Okay, what's a discrete probability function? A discrete probability function is a function where there are finite number of your outcomes, possible outcomes, finite number of possible outcomes. Okay, so when I say finite number of possible outcomes, it means, is simple example is rolling a die. 1, 2, 3, 4, 5, 6. When you roll a die, you have a finite number of possible outcomes. You cannot get 2.5, right? You cannot get 2.5, you cannot get 3.5. These are not possible. Either you can get 1, either you can get 2, either you can get 3, either you can get 4, 5, or 6. So the possible outcomes are only 6, right? So a lot of you will be saying, sir, this is true for every time. Like when you are tossing a coin, the possible outcomes are only 2. Either it is heads or either it is tails. But it's not so, right? Please understand that outcomes can be infinite also. So discrete has finite possible outcomes. Discrete has your finite possible outcomes. This is your finite. Continuous has infinite possible outcomes. Right? Now, digging deeper, digging deeper. Somebody will ask, sir, what do you mean by infinite possible outcomes? Simple example is, let's talk about this rainy season going on. Let's talk about rain. If it is raining right now, and it will rain, let's say, full day, can I tell how much rain it will happen? It can be anything, right? If it's raining slowly, maybe it is 1 mm, right? Maybe it's rained heavily, it might be 2 mm. Maybe it rains moderate, it might be 1.5 mm. And if I take it more thing, it can be 1.21, 1.22, right? 1.05, 1.07, 1.093, right? 1.212, 1.314, 2.212, 2.312, right? Can I tell what exactly will be the range? What will exactly will be the outcomes? Outcomes are infinite, right? It can be anything. Outcomes are infinite. It can be anything. Infinite outcomes, right? Infinite outcomes. It can be anything, right? So this kind of situation, when we are talking about possibility of how much rain we'll receive in a particular place, when it is raining, the possibilities are enormous, infinite. I cannot count, uncountable, right? Uncountable. Infinite means uncountable also, right? And finite means countable. So when the possibilities can be counted like this, countable, then it is called your discrete probability function. When the possibilities or outcomes cannot be counted, those are called infinite or uncountable. Okay, so that is the case. Okay, then it provides the probability of each outcome, right? It provides the probability of each outcome, right? That's okay. Properties, the property of each outcome must be between 0 and 1. I have told you in the first slide itself. In the world of probability, the possibility of the outcome is always between 0 and 1. The sum of the probabilities of all possible outcomes equal to 1, right? That's true, right? When you're taking all possible outcomes, the sum will always equal to 1 because we are considering 100% possibility. Okay, the confusion comes here. Confusion actually comes here from this part. So I am taking a screenshot of this part. I'm actually taking it to the next slide or next page, because I think the confusion which comes among people is that what is the discrete probability function and how to handle it, right? That is the confusion which comes to a lot of people, right? So this is where I want to resolve. See, why I'm telling you this is because till now you have seen your, what you say, the probabilities in different sense. You have seen the your probability of getting a 3 when you roll a die. So that time, what did you consider? You said that okay, total possibilities are 1, 2, 3, 4, 5, 6. Total possibilities are 1, 2, 3, 4, 5, 6. So out of that, I'm talking about one possibility 3, which is 1. And 6 possibility is 6. So 1 by 6. Right? Probability of getting a 3 when you roll a die, 1 by 6. Okay? So that is what we were considering. Right? Then, what's the next step? If I take the same scenario, let's say I say, what is the probability of getting a number 1 when total possibilities are 10. So you will say that okay, you're getting number 1, it is 1 by 10. If I'm asking you what is the probability of getting number 2, number, let's say number 1, number 2, number 2, you will say again it is 1 by 10. Okay, so this is what you have already studied. Okay, I'm stopping here what you have already studied. But please understand that was the calculation of probabilities. Now I am going in a different direction. I am talking about probability function. Probability, this was probability calculation. This is probability function calculation. Here the thing given to me is x by 10. So if I have been asked what is the probability of x is equal to 1, here I will say put the values on the thing given to me x by 10. I'll put the value of x, it becomes 1 by 10. So that is same. See, here also got I 1 by 10. Here also I got 1 by 10. But the problem comes is when I ask you probability of x is equal to 2. Right? Here I got x will go in the value here. So you 2 by 10. So you get 2 by 10. But in this case, number 2, it is still 1 by 10. You see the difference? Are you noticing the difference, guys? Please note, here it is still 1 by 10. Here it is 2 by 10. If I take it, what is the probability for number 3? If I take it, what is the probability for number 3? Let's say I take the probability for number 3. We will say again, number 3 is 1 out of 10, right? 1 out of 10. So it will probability is 1 out of 10, right? But if I put here on this side, in probability function, the probability becomes what? Probability of x equal to 3 becomes your 3 by 10. Okay, I'm not telling you this thing in detail here. This will come ahead, guys. But please understand, probability function is kind of a cumulative value. Probability function is kind of a cumulative value, right? And that's why when we are reaching at 3, it is becoming 1 by 10 plus 1 by 10 plus 1 by 10, right? So it is becoming 3 by 10, right? So when I'm asking you probability x equal to 3, I'm asking cumulative probability. That's why it is 3 by 10, right? That's why it is 3 by 10. But in this case, I'm asking probability only 1 by 10. Okay, I'm asking probability of only that event, number 1, number 2, number 3. I'm asking in this case, I am, let me write with other color. In this case, the first case, I am asking individual probability. Individual probability. Okay, individual probability. In this case, in the right hand side, I am asking about cumulative probability. So have a clear cut idea, guys. Have a clear cut idea. Don't get confused here. Both are different things, right? So read the question carefully. When you are asked probability function, it's a cumulative value, right? So even you're not understanding cumulative thing, just put the value of x equal to 1. See, if I'm asking here, it is asking you probability of x is equal to 4 in your this thing. It becomes, see, x by 10. So you put the x value 4, it becomes 4 by 10. Right? It's that straightforward, right? When x is equal to 2 or 4, so you take x equal to 2, right? 2 by 10, you take 4 by 10, you add, becomes 6 by 10, 60, right? And sum of probabilities will always be 100%, right? Which I told you earlier, which makes sense, right? Because sum of all individual events will always make it your 100%, right? That's very straightforward. Okay, so keep that in mind, right? Very, very interesting point. Sometimes students get confused here. Don't get confused, please. Moving on, guys, and this is where we'll test the understanding if you guys have really got the understanding or not, right? So we will try to test it here. Here what is happening is I'm trying to calculate the probability function for the outcome of your one roll of a six-sided die is given a x by 21. What is the probability of x greater than 4? Question asked is x greater than 4. Now we know what are the possibilities. Possibilities are 1, 2, 3, 4, 5, and 6. I am asking you your x greater than 4, which means I am asking you your 5 and 6, right? 5 and 6. So what will we do, right? Simple point is we'll take x is equal to 5. With x is equal to 5, you'll put here, right? Which becomes 5 by 21. We'll take probability of x is equal to 6. That becomes your 6 by 21, right? So the thing becomes your 5 by 21 plus 6 by 21, it becomes 11 by 21, right? If you add it, right? 5 by 21 plus 6 by 21, it becomes 11 by 21, and which is greater than 50%. So answer is 52.4, right? Which makes this, because denominator should have been 22 if it has to be 50%, right? So it makes it 52.4. Very simple. Okay. That's it, guys. That's a very simple and easy part, right? Now we are going into conditional and unconditional probability, right? Very important, guys. Very, very important part of the lecture, right? Conditional and conditional probabilities. See, unconditional probabilities, I have already discussed with you. It's the marginal probability, the probability of an event occurring without any other information, right? So again, I told you it's the simplest of the probabilities. When you talk about without any condition, the probability that the day's high temperature in Seattle will be between 70 and 80 degrees, right? Not putting any condition. Conditional probability is different, where you are putting a condition, right? I told you, right? You are saying, I give you an example of traffic and the rain, right? That if the traffic chances of traffic is 40%, if it's raining, it becomes 60%, right? Probability of A given B, the condition is B, right? And that's what I told you. Condition always come in denominator. Probability of A, B you have in numerator the condition, right, which is probability of B. Okay, so probability that the high temperature will be between 70 and 80 degrees given that the sky is cloudy that day. Okay, then we have the joint probabilities. We talk about the joint probabilities. What else we have here in joint probabilities? Now this is very tricky part. I don't know why. I told in the live class also to students that I don't know why a student get this part wrong. Right, I'm yet to figure out. The question, see, everybody understand conditional probability. But what happens in exam is they twist the question. So instead of asking your conditional probability, they ask you joint probability. Joint probability is PAB, right? Please understand that if they are independent events, right? If there are independent events, then it becomes very simple. PAB is equal to your PA into PB, right? It makes very simple. But this is only true if you have independent events. But not all events are independent. What happens that? So that case you have to use a simple thing that okay, I know probability of A dependent on a condition B, which gives me probability of A B, right? And in denominator will be the condition. Now if somebody asks me A B, right, what I'll do is probability of A B is equal to probability of A intersection B into your probability of B, right? So this is what we get, right? So very straightforward that when we have to find the joint probability, which is this, it becomes A conditional B multiplied by B, right? So this is the relationship, and you can do the rearrangement, which I told you, right? This is the rearrangement, so you already know. The point here is that read the question carefully, find out whether it's an independent event. If it's an independent event, then it is very straightforward, but examiner will not give you such straightforward question. We all know that FRM is not so easy. Generally, they will give you this kind of thing, so you need to figure out your way, right? The next part is very tricky, guys. This part, total probability law, is very tricky. So I'm putting this in next slide, right? The reason is that we need to discuss this deeper, right? In this slide, unfortunately, they haven't discussed so deeply, right? So we have to discuss that deeply. Okay. So I am actually okay. Let me put that part after this here. First, let's do the numerical. This numerical, then we'll focus here on your this part. This is very important to understand, guys. Why this is important to understand? Because total probability rule, if you understand, then only you can understand your Bayes theorem, right? Very important. Okay, keep that in mind. So now going back, if I go back, so I'm just we'll do it later, right? This part, uh, this part I am holding it right now. This part I am holding it that we will do later. Let's solve the numericals first. Okay, when we solve the numericals, what we get here is the relationship between probability that both event A and event B will occur and the conditional probability of event A given that event B occurs, right, is what, right? It is your what you say, this part, probability of your AB, right? So we are testing these formula, right? Basically, we are testing this formula. You already know that probability of AB is equal to probability of A, right, into B. How did I get here? Because I know that probability of A condition on B is equal to probability of AB, right, dependent on probability of B. So basically you multiply, right? So this makes sense, right? This makes sense, right? This seems correct formula. What about next formula? So next formula is, if you check again, if you see second formula, which I'm doing it here. So probability of A you multiply with probability of AB, right? It gives you probability of A intersection B, which is actually not true, right? Which is actually not true because probability of AB, something has to be divided, right? So this doesn't make sense. This part again you have probability of A into your probability of A intersection B is equal to probability of AB. Here things look very similar, but the point here is it's probability of B, the condition which is multiplied, not the main criteria, right? Condition we have to multiply. So this is also wrong. Right? It should have been PB, guys. Right? What about this part? Again, probability of your AB is given as probability of A condition on B multiplied by your probability of A. Right? So what is happening here? AB is equal to A intersection B, right, into PB, right? So it's a PB. So this is also wrong, right? So point here is, if you know the formula, you are sorted here. If you don't know the formula, you're gone, right? So remember the formula, guys. Remember the formula, very, very important, right? The smart student will understand that FRM relies a lot on your conceptual clarity as well as your remembering of properties. You have to focus on conceptual clarity also and remembering the properties. Okay, so that's what we have here, guys. This is okay. So this answer is A, that we got it. Okay, that's we have to discuss this, and then we have the base theorem, right? This is typical, right? This is not easy to understand, and I'm focusing here because this is kind of your base work, right? This is kind of a base work for your, what you say, the understanding of the base theorem. Okay, so we'll do the base theorem today in the class, but the objective is that we need to figure out this thing very holistically here, right? Total probability law. When I talk about total probability rule or law, point here is that first of all understand there are two conditions. One is mutually exclusive, other is exhaustive, right? First of all, figure out these two conditions. One is your mutually exclusive, other is your exhaustive. Okay, when I say mutually exclusive, right, what it means is that if an event is in one place, it cannot be another place. Now you will say, sir, what do you mean by that? Let's say, in fact, the numerical which we'll do is very similar. Let's say there is a company, right? There is a company which has three different kind of employees. Employees A category, employees B category, employees C category. C category employees are your with no degrees. B category employees are with your bachelor degrees. A category employees are with higher than bachelor degrees. And then I tell you that the company, and I tell you very clearly that in this company, if you are part of A category, you cannot be part of, let's say there is employee X. If an employee, let's say X, is part of your A category, he cannot be part of your B and C category. Means basically you can belong to only one category. Mutually exclusive means you can belong to only one category. Okay, so keep that in mind. Moving on, right? Moving on. Next is your exhaustive. When I say exhaustive, what it means is that you also need to check if you want to apply your total probability law, if you want to apply total probability rule, you have to check for these two conditions, guys. Condition number one and condition number two. You also have to check whether categories which I have considered are exhaustive in nature or not. Okay. If that is the case, right? If that is the case, so when I say this exhaustive or not, basically I'm trying to tell you, you should see that if, let's say, there are 100 employees in the company, let's say 100 employees in a company, okay, if there are 100 employees in the company, right, then what do you do, right? The 100 employees in the company, what do you do? Then you check whether we have divided the categories into A, B, and C. The sum of employees in A, B, C category equal to 100. Basically, please check this. Let's say A is consisting of 60 employees, B is consisting of 30 employees, C consisting of 10 employees, right? So it makes it 100, right? If that is the case, see, 100 is a number I have taken thing, but eventually what it means is that you should get 100%, right? So it can be 60%, 30%, and 10%. So basically, you should have a exhaustive kind of thing, right? You should have your exhaustive nature. The categories which you have taken, those should be exhaustive, right? So before even applying your total probability rule, you should be very clear that if I want to apply total probability rule, I should first meet these two conditions. The first condition is mutually exclusive, which I have explained earlier, that there are three categories. If an employee, let's say X, is part of A, it cannot be part of B and C. You can only belong to one category, right? You cannot get into two different categories. All categories are mutually exclusive, and you can only belong to one category. Second is exhaustive, means you also need to check whether categories are exhaustive in nature or not. Let's say 100 employees, then 100 employees are 60, 30, 10, right? So you're covering all, right? In case, let's say you have 100 employees and you have made three categories, let's say A, B, C, and let's say your A has 50 employees, B has 20 employees, C has 20 employees. So this is making 90, right? So then this, you cannot apply this total probability law, right? You can't apply. To apply your total probability law or rule, you have to have exhaustive nature, right? You need to have 100%. If you don't have, forget it. If you don't have mutual exclusive, let's say a person can be in category A also, and category B also, and category C also, then you can't apply this rule, total probability rule. So before you even think of applying total probability rule, right, what you need to focus is that you understand that you have to meet these two conditions, right? Please keep that in mind. Okay, very, very clearly, please understand it. Okay, what we will do now is we will do a question on this uh, in our understanding, because if we understand the question, then only we can go to the base theorem, right? Okay, which is the next part, which will I'll take in the next lecture. Okay, put in the live lecture I'll take. So what we can do is I can quickly open your Schwezer, right, and we can solve a question. Right, I can quickly open Schwezer and we can try to resolve a question, right? So it's a very lengthy kind of question, but I think that gives a lot of idea what we need to keep in mind, right? So we'll do it slowly, guys. No rush. This is directly taken from Schweitzer, guys. Directly taken from Schweitzer. Objective is that you understand nothing else. Okay. So it's directly taken from Schweitzer. Okay. So the first discussion in this question, right? First discussion in this question is about your conditional probability, right? So I picked up a screenshot from your Schweitzer, guys. Very, very straightforward, right? So we'll try to understand that, okay, suppose we are interested in the probability of an event given that some other event has occurred. That's a conditional probability. We all know that, right? We have studied this already. What's a conditional probability? Now, consider conditional probability. Consider your conditional probability that an employee at Acme, right, earns more than 40% per year, right? So we are considering only an employee which is, earning more than $40,000 a year. Condition on the highest level of education. So an employee has attained. So employees fall into three basic education categories: no degree, bachelor degree, and higher than bachelor degree. So I have told you very clearly three categories, right? First category is no degree. Second category is your bachelor degree. Third category is your higher than bachelor degree. Three categories, right? If 60% of the employees have no degree, so 60% employees here. I've given a very similar example, guys, so that you understand, right? 30% of the employees have attained bachelor degree, which come here, and last is your 10% have attained a higher degree, so which is 10%. So what are we getting here? You see here, probability of ND 60, probability of BD 30, probability HBD 10, right? So the first thing which you should come to your mind is that if I have to apply the total probability law, these things have to meet 100%, right? So you sum it up and you realize that this is 100%, right? This means that it is exhaustive. It means that you have covered all kind of employees, right? No kind of employee is left. Okay. Now also note, right? Another point which your book is stressing here is, right? Also note that there are three levels of education are mutually exclusive. So they are giving you that, right? So we are very happy, right? We have got mutually exclusive also. So our two condition, one is exhaustive, other is mutually exclusive, both are met. Employee can only be in one of these three categories of education attainment. Note also that the three categories are also exhaustive, which I had already told you, right? Cover all possible levels of education attainment. We can write ND, probability of ND or BD or HBD. This is just a mathematical way of writing probability of ND or BD or HBD, right, is equal to 100%. This is just the union, guys, or is union, right? I don't want to get into that kind of mathematics here, but anybody who is getting troubled here, just for that person, that ND union BD union HBD, mathematical formula which we take it, this makes it 100%. Okay, so this is what we have, right? This is what we have very, very clearly, that we want this kind of thing. Okay, now we understood this very clearly. Once we have understood this, for the next part, given a conditional probability and the unconditional probability of the conditioning event, we can calculate the joint probability of both events, right? How do you calculate the joint probability? I told you, right, very clearly. If I have to calculate the joint probability AB, one way is that I think of whether the events are independent or not. So clearly here events are not independent. If the events were independent, if independent, if independent, the thing would have been probability of A into probability of B. But no, events here are not independent, right? If events are not independent, then I clearly know that if I have to find probability, joint probability A, B, I have to rely on your conditional probability. A intersection B into probability of your B. Okay, that is what you have here, right? That you multiply this part, right? This part, which I mentioned here. Okay, now assume, right? What the book is saying is now assume that the Acme 10% of employees with no degrees, right? 70% of employees with only a bachelor degree, and 100% of employees with a degree beyond a bachelor degree earn more than 40%, $40,000. So what it's saying is that probability of earning $40,000 plus, 40K plus, dependent on the category which we have, right, which is no degree, is 10% people. Let me write it here. Okay, just give me a second, guys. Just the probability of your 40K on no degree, probability of 40K plus with no degree is given to you as what? 10%, right? 10%. Probability of your 40K plus, right, with your bachelor's degree, right, is equal to your what? You read the question carefully. 70%, right? And your probability of your 40K plus with HBD, right, with the condition of HBD, higher bachelor degree, is equal to your 100%. Okay, so the three categories, right, different categories. Okay, using these conditional probabilities along with your unconditional probability, right? Why? This is the total probability rule, guys. This is the total probability rule, right? If I go back now, I'll explain you total probability rule, right? Till now, I was building the basics. This is your total probability rule, guys. Total probability rule says, or if I again take it ahead, first was the conditions which we discussed. Okay, now I am moving into your understanding of total probability rule, right? So let's build the understanding of that. See, total probability rule says that if you meet the conditions which I have specified, right, which is the mutually exclusive and your exhaustive events, right, which I specify. If that is the case, right, if that is the case, please note that probability of any event can be written as summation of, right, probability of that event dependent on its condition multiplied by a probability of that condition. See, when you look at this theoretically, it doesn't make much sense. But if you look at practically, you say that there are different conditions which exist. So you'll say that let's say there are three conditions. If there are three conditions, it becomes probability of A for condition 1 into your probability of condition 1 plus probability of A condition on B2 into your probability of B2, right? Probability of A conditional on B3, right? Into your probability of B3, right? So basically, this is how if you have three conditions. Now coming back to the same kind of questions, we have three different kind of conditions. We have three different kind of condition which are mutually exclusive and you're exhaustive. What were those? No degrees, bachelor degree, and HBD, higher bachelor degree. So what I can say is that if I'm saying probability of earning 40k, let's say I'm trying to find probability of earning 40k plus in company, right? So it boils down to probability of 40k plus. What is the first condition? The first condition is your no degree. Then multiplied with probability of no degree. What's the second condition? Second condition is probability of your 40k plus with your second condition, which is bachelor degree. You are multiplying with probability of your bachelor degree. Third is probability of your 40k plus with your HBD, higher than bachelor degree. So multiply with probability of your HBD, your higher bachelor degree. Okay. So this is what we are doing, right? This is whole thing which we are doing. So and we have the values for this, right? So what I'm trying to break it down here is that once your two conditions are met, condition number one and condition number two are met, okay, thereafter it's not difficult, right? Thereafter it is not difficult because you have to just apply the total probability rule, which I told you three conditions. You like this a by b1 into pb1, a by b2 into pb2, a by b3 into pb3, and this I have given you, right? See, this is here. If you want to learn much deeper, please understand. ND is your b1, first condition. This is b2, and this is b3, right? I've just put, this is b1, this is b2, this is b3. Okay, so this is what we have, right? This is how it is structured. Okay, keep that in mind very clearly. All right, this is your total probability rule, guys. Very clearly, this is your total probability rule which we need to keep in mind. Okay, using these conditional probabilities, right? Using these conditional probabilities along with the unconditional probabilities of your P and D, 60%, which I told you, 30% I told you, 10%, we can calculate the joint probability, right? This is what your book is talking about. Same thing. What I'll do now is, once you have understood this, I'll click another screenshot and put it here so that you should know how it is done in your book. Right? Just give me a second. Okay. All right. So here, what you need to focus is same thing, right? This was what? What is this? This is your probability of your 40k plus dependent on your condition of ND, right? And this is your probability of your ND. The ND is the probability of how many your non-degree employees are there, 60%, right? You are getting this. Similarly here, this is for 70% is what? Probability of 40k plus for your bachelor degree, right? It is given to you, multiplied by probability of your bachelor degree. What about this? Probability of your 40K plus for your HBD, multiplied with your probability of your HBD, right? Which is given here 100% into 10%, which is 10%. Okay. So we can use these probabilities to illustrate the total probability law, which I told you this thing, that you have three conditions. One condition A1, AB1, B1, AB2, B2, and AB3, B3. This is the sum of the joint probabilities. For a company Acme, we will have combined thing, which is 6%, 21%, 10%, which gives you 37, and the employees earn more than 40% is 37, right? Which, if you go back, this is what I was talking, right? So basically, you have added these things and you get the answer, right? 37%. Probability of 40K plus in a company, right? How many people are there in 40K plus in a company is your 37%, right? Because this came out as your 6%, right? This came out your 21%. This came out as your 10%, right? You can go back and revise it, guys. Not very difficult, but this concept is very important if you want to understand the total probability law, or the Bayes theorem also here, right? Also, what they have done is that you can use a, you can expand this thing ahead also to conditional probabilities also, rearranging. If I have to find your, you know conditional probability, or rearranging, I need to find joint probability. So if you needed to find your conditional probability, right? Conditional probability, which is P A dependent on B, if I have to find, it becomes your PAB divided by PB. And PAB is, let's say, that if we can calculate a conditional probability from the joint probability of two events and the unconditional probability of the, as an example, the conditional probability of 40 plus BD, right? So if you have to find your similar, right? It's a, rehashing, I would say. If I have to find 40 plus BD, I know, right? I have to take 40 probability of 40 plus and BD, because it's a intersection I have to take, and I have to take probability of BD, right? Which is your 21% and your 30% is equal to your 70%. Okay, that's what we get, right? That's what we get very, very clearly. Okay, not very difficult, not very easy, but very important to understand if you are looking to understand your Bayes theorem properly, guys. Okay, keep that in mind. If you're looking to understand Bayes theorem properly, this is very, very vital because it will be used ahead. Okay, keep that in mind. Moving on, next is your Bayes rule. I'll cover it just generally, the definition part, which I covered in the lecture also in the class, and then in the next set of lecture I'll go deeper, right? So Bayes rule, the purpose is to allow us to update on our estimates of the unconditional probability. Basically, in case in case we get new information, how can we update the probabilities, right? So that is using new information. In case we get a new information, it allows us to update our probabilities or estimates. Okay. First of all, we need to remember the Bayes formula. It is PAB is equal to, please understand, it is exactly opposite. We'll take PB by A into your probability of A into your probability of B. It's not difficult at all, guys. No, please understand. When you're taking A conditional on B, basically the context here is that when finding probability of A depending on condition B is extremely difficult, we should know Bayes' theorem, because Bayes' theorem flips it. Bayes' theorem says that, okay, if the opposite is easy, use that. Sometimes what happens is you are not given P A dependent on B, rather you are given P B dependent on A. So you should know how to go from P A dependent on B or A conditional on B to P B conditional on A. And also remember, this is the B which is condition always come in denominator. So please remember, this will be denominator. Since this has been put in denominator, please remember that in numerator we also have to multiply something. So this is coming like this. So remembering Bayes' theorem is not a difficult thing. Understanding the context is different, right? Understanding the context is very important. Context here is that please keep in mind very, very clearly that if I have to calculate your A dependent on B or A conditional on B, sometimes it is not easy to calculate. It's not easy to calculate at all. If that is not easy to calculate, what do I do? What do I do? So I should have a funda. I should have a means by which I can convert your A dependent or A conditional on B to B conditional on A, and also depend then change the formula, right? A condition comes in the denominator and P into A, right? So this is the essence of the Bayes rule, right? Essence of the Bayes rule I have given, that it is a way to simplify things. It's a way to understand, or it allows us to update on our estimates or probabilities when we get a new set of information, right? So this is a method to update on our estimates for the probability when we get a new set of information, right? To keep that in mind. And it also tells you that if it can't find A probability of A dependent on or conditional on B, we should be, and if the opposite we can find easily, probability of B conditional on A, we should be able to like we can use that, and there is a relationship between A conditional on B is equal to P B conditional on A into P A into PB, right? Second part which I want to take away, or which I want you to remember before we cover this lecture in the next slide or next lecture, is that you also need to remember this part, right? Which we also need to remember this part. We'll discuss this more, but what is important to remember here is that total probability rule is very important to understand, right? So total probability rule, that using the conditions, right? So you should very clearly understand that probability of A is equal to your summation of probability of your A dependent on your B chi conditions into your probability of BI, right? So you should remember this part, and then expansion you already know, right? Probability of A, if I have to expand, right, it is given as your summation of your probability of A dependent on a condition B1 into your probability of B1. Now here is a small twist. Small twist is that the second is we have taken AC, which is the complement of A. Sometimes when you don't have anything, right, you don't, not many conditions given, right, you should know that you can also a kind of, if I write it for this summation I have used, so if I have to write it like A dependent on a certain condition, let's say B, and I am writing that PB, it is multiplied. The second condition I can take is probability of A dependent on your B complementary condition, and into your probability of B complement, right? Condition B complement. So the point which I am trying to suggest, right? Point which I'm trying to suggest here is that be right. Point which I want to suggest here is that you should be very clear about this part, that total probability rule plays a very important role in understanding of Bayes theorem. See, this PB is for the denominator, right? You should always remember that in FRM, especially when a question will come on your Bayes rule, right? In Bayes rule or Bayes theorem, it will come, right? You should know that the denominator, if they give you easily, you should be very happy. But normally they will not give you very easily, because FRM is trying to test your knowledge, right? So they will not make it super easy that you can easily uh, understand it and solve it, right? They will not do that. So they will give it in a tricky way. So you should know that how do you calculate the denominator. If the condition is given to you, right, you can solve it by total probability rule. If not given to you, you should also know that you can create a complementary condition of A. We will see that in our lecture, right? We'll see that in the live lecture. So basically, intuition here is very interesting. Please understand that intuition here is that it links the conditional probability of A given B to the conditional probability of B given A, incorporating the prior unconditional probabilities of A and B, right? So right now you might not understand, but the problem here is when we solve numerical, you will realize you are kind of linking conditional probability of A given B, which is this part, right, to the conditional probability of B given A, which is this part, right, incorporating the prior unconditional probabilities, which is PA and PP, right? So right now, my suggestion, we'll stop here, but right now my suggestion to all of you guys is that before you move on to the next lecture, please go back and revise this formula very, very holistically. And also, please have a solid grasp over your total probability rule, because if you don't understand total probability rule, Bayes theorem will be very difficult to understand. Because Bayes theorem, the denominator 99% of time will be found by your total probability rule only, right? This is no denominator, I'm writing it here very clearly, that denominator in your Bayes rule, you generally, you know you use total probability law. Right? You use total probability law, right? So keep that in mind, right? Keep that in very, very clearly in mind, that you have to remember it. Okay. And then the formula you have to remember. Before we wrap up this lecture, I'll stop here. We have to do the question, but we'll do in the next class. Before I wrap up, please let's kind of summarize what we have studied. I'm going back to quickly summarize what I have studied. If you go back, that we started with the first lecture of our basics of probability, right? The basics of probability we needed to understand. And when we started with the first set of lecture, we needed to focus on basics of probability and conditional, unconditional joint probability. I told you here, independent, mutually exclusive event, go deep, understand the formula, remember it. Conditionally independent, tricky, focus more on theory, less on the numericals. I told you for the fourth topic, right? Then we went into basics of probability, where we talked about definition of conditional probability, definition of unconditional probability, definition of joint probability. I told you what are the values probability lies, what exactly is a random event, what's a probability interpretation. Then we saw this formula, what is the joint probability, conditional probability, right? Okay, we understood that part, right? And then we moved to event and event spaces. We understood what are event and event spaces. Then moved to the practice question for that. Then we moved to independent and mutually exclusive events. I've highlighted, I made a lot of stars, almost 6 stars here. Please focus here, guys. It is very, very important. They will test you on this. Then I've given you some understanding for general formula, mutually exclusive kind of thing. Then we did the practice question, we solved the numericals. Then I moved to conditionally independent events. I told you here I made a star, 2, 3 star at the one place to tell you that here numericals will not come. Mostly, theory will come. We have two example. One example I have written in green color, which is that events were independent earlier, but due to some uh, some new event, right, they have become kind of dependent. Earlier events were independent, but on condition they became dependent. And the yellow example which is given in the slide is earlier events were dependent, but on new event, when age equals to 8 comes, they become independent. So that's why we had vice versa, right? Remember this, guys. This is very important, that events can be independent but become conditionally dependent. Event can be conditionally dependent, can become independent. Both examples have been given here, guys. This is a very good slide in that sense. Like, one example was already given, one I have given. So this becomes very clear. Don't focus on the numerical here. I have never seen last 15 years ever a numerical come here. Mostly question will come here on your understanding of theory. Right, so focus here. So this is property. I told you C is the answer. We solve it. Cannot be must cannot be cannot, and only if cannot be. Right. So that's what we did. Then we move to your conditional and unconditional joint probability. Here I told you about discrete probability function. I made you understand what is a continuous probability function, what is a discrete probability function. Even though continuous probability function in the next chapter, but you should have certain idea that it means uncountable, it means infinite. Discrete means countable, right? And then there are two properties: the probability of each outcome between 0 and 1, which is okay. The sum of probability of all possible outcome must be equal to 1, which we also know, we should know, right? So that's what we did. And then I explained you this part because this is very confusing, where students get confused. Please understand, probability function is a cumulative value. Earlier we were doing probability, right? Probability is different, probability function is different, right? So we are doing that. I'm asking here about cumulative value, so we should be very clear whether it's a cumulative value being asked or a normal probability, right? Then we move to this part, which is 5 by 21, 6 by 21, all that thing. And we solve the numerical, right? We solve a numerical for the cumulative part. So you should be very clear, cumulative part we have to solve, right? And here we move to conditional and unconditional probability. Not very difficult, quite easy, right? We have seen earlier also, but you need to remember a lot of time, right? I'll put a stress or make a star mark here, guys. A lot of people underestimate this, but a lot of time question comes on a joint probability. So it's an important topic. Joint probability looks very simpler, but what happens in exam is suddenly they will twist the question so much that finding joint probability becomes difficult. Why joint probability will become difficult? Because to find joint probability, right? If independent events, it's okay, but if it is a normal event, right, dependent event, right, then you have to find your joint probability. To find joint probability, sometimes you have to first calculate this part, right? So first calculate this part, then multiply by this part, then you get the joint probability. So it becomes difficult. And then once you have understood that, then the total probability law which I focus on, that the total probability rule also you need to focus very, very efficiently, where I discuss. First we did the numerical, that please, if you have the understanding of numeric formula, you just have to see which formula makes sense, which was easy. So focus on the numerical, guys. Focus on the formula. Formula is very important, very, very important. Conceptual clarity and remembering the property is very, very important. Then we moved here to understanding the total probability rule. I told you very clearly that there are two conditions. What is a mutually exclusive condition? One is an exhaustive event. Both has to be met, and explain them very, very clearly. Mutually exclusive means you cannot belong to other categories, you have to belong to one category, right? That's very, very important. In your exhaustive events, you have to you have to cover every kind of thing, right? You have to cover every other kind of thing. So be very, very clear that exhaustive means all employees have to be covered. In case any employees are left, right, you are 90% employees, 90 employees, etc., then you can't use it. The total probability rule, if you think of applying, first you check these conditions: mutual exclusive and exhaustive, right? Especially exhaustive. Mutual exclusive might be given to you in exam clearly, but exhaustiveness is your duty to check, right? Please understand what I'm saying right now. Mutual exclusive, most of the time it is given, right? Mutually exclusive, most of the time it is given, right? It is given in the exam. But the problem comes is that you have to check the exhaustiveness yourself. This part is given, right? This part is given in very clearly. What you have to check is your exhaustiveness, right? You have to check exhaustiveness, and exhaustiveness, when you try to check, right? Then exhaustiveness, check, please remember exhaustiveness. Okay, exhaustive property, right? You have to check. Okay, you have to check exhaustive property. You have to check. Okay. Then moving on, yeah, this is the numerical application from Schwezer. Objective was to clearly show you how to do your understanding of your total probability rule, right? By incorporating not only one thing but many things, right? So we here incorporated your conditional probability, then we kind of went into exhaustive nature, we went into mutually exclusive things, we covered if independent, what to do, if events are not independent, what to do, right? What do you mean by this part? How do you understand? How do we calculate this part, and this part, right? Using these conditional probabilities along with your unconditional probabilities, we have this part, this part, this part. We calculate the joint probabilities, right? So we have done it. Then I went back again to teach you about your joint probabilities, that how do you write it, right? So when you have three different conditions, right? When you have three different conditions, right? Your condition number B1, B2, B3, how do you put that in formula, which is this, B1 here, B2 here, B3 here, then we put that in formulas. So what was happening here, if you, I don't know if you remember or not now, but if you go back to the data which we have seen earlier, then what was the data here? This was your, 60%, right? And this was your 10% employees which were earning, right? This was 100% employees, right? 100%, but employees in HBD was 10%, right here. And here 40K plus, uh, I think this was your 30% employees was here, right? 30% employees were in this category, 60 plus 30, 90 plus 10, 100, so exhaustive. And here it was your 70% employees were earning, right? 70% employees were earning about $40,000, right? So you see yourself. I have checked the exhaustiveness also. Exhaustiveness is 60% plus 30% plus 10%. 60 plus 30 ND plus your BD plus HBD, right? 60 plus 30 plus 10, it is making your 100, right? That is why you had this thing, right? Three conditions you have, right? Which means probability of your ND union BD, right? BD union HBD is equal to your 100, right? This is what we get, 100, right? We have to check this as well. So once we have done that, okay, what do we do? Once we have done that, we move to this calculation which is given here, and then we also see, right, what we also see here is that we have your what, we are trying to put total probability rule, which I have done. Then we see each one of them, right? 6%, your 21% and 10%. We do each one of them, right? And then we solve it and see. Please keep in mind that this is the calculation for your conditional probability, right? This is a calculation for your conditional probability, right? This is a calculation for your conditional probability. You should know how to go from one thing to another. So basically this question is very interesting because you're calculating different things. So conditional probabilities calculate 70%. So we are getting the same thing back, right? This was given in the question itself, but objective is not that. Objective is to relate that how we can go from one thing to another and come back to another thing, right? So you should see, as a student, your mind should work in this way, that you should be able to know how can I go from conditional to your total probability, How can I go from independent event and mutually exclusive event to something else? What's the relationship of independent event to mutually exclusive events, right? What's the relationship of independent events to conditionally independent thing? What's the relationship of each of these things, right? So you have to draw a mental diagram, right? You have to have a very good mental clarity that you understand each of them, right? So if you want, I can add here a few points before we wrap up this lecture, right? Okay, before we go ahead, right, I can write it down. What is important to understand, right? Since we are almost kind of good, the next base theorem has to be covered in the next lecture. But what I want to tell you here is that you read about your independent events, you read about your mutually exclusive events, you read about your conditional probability, right? Conditional probability, right? You read about your conditionally independent events, conditionally, okay, conditionally independent events, right? You read about your joint probabilities, right? You read about joint probabilities. You read about your total probability law, right? Okay, you are reading about your Bayes, right? Bayes rule, right? You read about marginal probabilities. Ultimately, a good student should look at your interconnections. You should know how this is related to this, this is related to this, this is related to this. You should be able to have your interconnections very clearly in your mind, right? How each thing is related to each thing. If you are able to, maybe I have not made it very clearly, but the point which I'm trying to say is you should be very clear how each thing is related to other thing, right? So interconnections is very important, right? Ability to understand interconnectedness, that separates a brilliant student from a normal student, right? So you should have interconnectedness or interconnections understanding, right? Build that understanding, guys. When I was teaching you this chapter, right, my only point was to go deliberate and slow in your total probability rule. Was that I wanted to build your interconnected or interconnections. You should be very clear. Smart students will understand that there are many interconnections here which has to be understood very very clearly. Okay, so keep that in mind. Then we go to your Bayes rule. Bayes rule, I told you very clearly that it allows us to update our kind of estimates of the unconditional probability of how, right? Because we get a new information, so we should know that the intuition part very very clearly, that it is linking the conditional probability of a given b to the exactly opposite, to the conditional probability of b given a, right? So what are we doing here is we are saying that maybe sometime calculating probability of a given b is not easy. If probability of calculating a given b is not easy, we can calculate probability of b given a, if that is easy to calculate, and then we can use PA and PP, right? So your mind should work that if a given b is not easy to calculate, can I find b given a easily, right? That's the first point. Second is the denominator part. Like P A given B is equal to P B given A into P A divided by P B. The P B part, the denominator part in Bayes theorem, I wrote it in the blue color also. The denominator in Bayes rule will not be given to you so easily directly, right? If it is given to you, you should consider yourself very, very lucky, right? But I'm telling you in FRM, this is the main part which they want to trouble students. They will not give you denominator in Bayes rule easily, right? So you will not get denominator easily. You have to go to your use your total probability law, and while using total probability law also it will not be easy. Why it will not be easy? Because the conditions will not be given to you. So you have to be smart here, right? You have to smart here because there will be adequate hint in the question that there are only two conditions. One is simple condition, one is the complementary condition. So you see A, you see that the formula for the total probability law, which is written here, probability of B is equal to probability of B dependent on A into PA, and probability of B dependent on AC into probability of AC. What do you mean by that? Why it is given AC? You have not seen AC in your total probability law, right? You are seeing AC here only, right? AC is what? Means here, the condition is your, or BC you can say, right? So the point here is the condition which is given here is complement, right? It's a complement. I have written PB value, guys, kind of thing. So yeah, I have written in that way. I have written PA, probability of A. The slide it is given PB, so means the same thing. Both places we are taking the condition only, complementary condition. But what I'm trying to put across is that there will be adequate hint in the question to tell you that there are only two conditions in the denominator. That is one trick. But sometimes there can be many conditions also, right? It's not necessary there will be two conditions only. Sometimes there can be many conditions also. So keep that in mind. It's not necessary that there will be only one condition. There can be many other conditions also. So we have to figure it out. So denominator in your, what you say, in the Bayes rule is very tricky to figure out. That is one of the trick you need to have clearly in your mind, right? So keep that very, very clearly, guys. Very, very important it is. As a student, you need to clearly know how we can go from one thing to another, interconnections. That is where you will become good at probability. It's not about mugging up. It's not about remembering the stuff. It is more about understanding it deeply, right? If you understand why, that why we are doing, why we are going from probability of A dependent on B to probability of B dependent on A. Why? Because sometimes probability of A dependent on B is not easy to find. So sometimes probability of B dependent on A is very easy to find out. So if that is the case, we can quickly flip and get to our objective, right? That's the thing. And sometimes the probability of B, which is by the total probability rule, it's not easy to figure out. In that case, we should know that if not easy to figure out, we can use the complementary condition. Okay, so we'll discuss that in the next class. But that's it from my side in this lecture, guys. Go back, revise it. I've covered it in a lot of detail. So thank you very much.